Hi dear students, today we have come with a new video of class 11, that is motion in straight line. Though in class 11 it is newer for you, but you have already read it in class 9. Most of the portion you have read. Here you have to learn little more. You can say that in class 11 from this chapter the physics has been started. Earlier, whenever we have read units and measurements, these you can say it is one of the tools to learn the physics. Okay, and here officially we have giving an introduction or going inside in physics of class 11. In class 11, our main target is to learn mechanics. Some of you very much aware of this term, some of you are not. So in motion in straight line you can say it is the starting of mechanics, but before that we have to learn what is mechanics. Mechanics is a part of physics where we have to study the rest and motion of the body along with its cause. The rest and motion of a body along with its cause. And to be giving more specialization, we are learning classical mechanics. Okay, so why it is known as classical mechanics? Because here we have to learn the rest and motion of macro elements. Macro element means the elements which we can able to see by our naked eye. These particles or these elements are known as macro elements. That is classical mechanics. And when we are talking about micro elements, then it will be changed to quantum mechanics, and that is higher physics. I think you will not read it. You will read a very small portion of quantum mechanics in class 12. But in class 11, most of the time you have to read classical mechanics. In classical mechanics, whenever we have to start it, there are three parts. First one, it is known as statics. Second one, it is known as kinematics. And third one, it is known as dynamics. What is statics? Now, when we have studied the physics of the body which is in rest, that part of physics is known as statics, where we have to study about rest body. Kinematics, where we have to study about the motion of a body without its cause of motion. Means where we have to study about motion, but we don't want to study about the cause of its motion. What is our target? That is motion in straight line. So motion in straight line means where you have to learn kinematics, that is motion of a body, but we are not bothered about the cause of the motion. And dynamic means here also we have to learn about motion along with the cause of it. We have to learn the cause of its motion, and that we have to learn in laws of motion chapter. In laws of motion we have to learn about dynamics, but now our target is kinematics. So whenever we have to told about the starting of the kinematics, it is starting about rest and motion, and I am not thinking that it is needed to be explained to you. What is rest, what is motion, you have learned it from class 6. Rest means when a body doesn't change its position with respect to some object. Motion means when a body changes position with respect to some objects. So to represent a motion, we need some object with respect to which it changes its position, and that fixed objects which represent the motion, that is known as frame of reference. I think you have learned it earlier also. Okay. Next, whenever we are talking about motion and rest, this rest and motion are relative to each other. That is also you have learned in class 6. Why? Because with respect to some fixed object, if a body is motion, with respect to another fixed object, maybe the body is not in motion. Just like whenever you are coming to school from your bus stop, then with respect to your parents, you are moving by bus. That means you are in motion. But with respect to your friend who is sitting beside you, or with respect to another friends, those who are inside the bus, you are static because you are just sitting in one seat. So whenever I have changed the frame of reference, then that rest and motion is changed. So it is told rest and motion is relative to each other, and it is told no body is in eternal rest, because we know all the particles in our universe, they are moving. So no body is at rest. So as no body is at rest, so no body, we can say it is in eternal motion, because with respect to a rest body, we can say the body is in motion. So if no body is at rest, so to talking about eternal motion, no body is in eternal motion. So it is simply the example. Now, depending the representation of motion, how we represent the motion of a body, we can divide it into three types. Okay, it is called one dimensional, two dimensional, and three dimensional. Motion. So I am just mentioning this portion because these are little newer for you. Assume if a body is moving in a straight line. So this motion, if a body is moving in a straight line, either in this direction or in upward, whatever the direction may be, here we can represent the motion by one coordinate. We know coordinates, that is x, y and z. These are three coordinates. So to represent the position of a body, we need to take the help of three coordinates. But if a body moves, assume along x-axis only, so to represent its motion, we need only one coordinate, that is x. Y and z, it is not needed because the body is moving along x-axis only. Okay, so that type of motion is known as motion in one dimension or motion in straight line. So our main study to learn about the motion in one dimension. Two dimension is, assume if ant is moving on your floor. Okay, so it can move in any direction. So if I just want to represent the motion, we need both x and y coordinate. So here we need two coordinates to represent its motion. So this type of motion is known as two-dimensional motion. Assume if a fly, okay, it is moving inside your room, or a mosquito is moving inside your room. So your room is three-dimensional. So to represent the position of the fly, we need both x, y and z coordinates, that is three coordinates. And that type of motion is called three-dimensional motion. So depending on the coordinates, depending on the position, we can divide the motion into three parts. If it is only in one direction, that is one coordinate, it is known as one-dimensional motion. If it needs two coordinates, it is two-dimensional. If it needs three coordinates, it is three-dimensional motion. Okay, that is the introduction part of motion in straight line. Now I am coming to very common thing. So to represent the motion, to understand the motion, we need to learn about some common quantities, just like distance, displacement. What is the definition? I will not say it, because I think you know that very much better than me about the definition, difference, distance and displacement, then speed, velocity, okay, acceleration, retardation. So this one I will not explain, because I have already told the preliminary things what you have learned in class 9, that you have to read it by your own. These I don't have much time to represent what is distance, displacement, speed, velocity, acceleration, retardation. I am not one to explain to you. It is your responsibility to read. Now coming to, whenever we are talking about speed, if a body covers equal distance in equal interval of time, we can say that the body is moving with uniform speed. Okay, and here with uniform speed we don't have any problem. If I want to represent it by a graph, by a distance time graph, it should be a straight line. But problem is that if the body is moving with variable speed. Variable speed means if in every equal time interval the distance covered by body, it is not constant. Like if the graph seems to be like this, it is distance time, the graph seems to be like this. It is not a straight line, and then it is known as variable speed. Assume if the body moves in a variable speed, then it is told you to find the total speed of the body. What you are finding there? You just find their average speed in general. So assume the body covers different distance in equal interval of time. So assume in first t second it covers x1, in second t second it covers x2, in third t second it covers x3, just like in nth time t second it covers xn. So this sum of the total distance by sum of total time, sum of distance by sum of times is known as average speed, and we are also very much familiar with this concept, that is average speed. But problem is, assume you are moving by your bike or you are moving by your car. There is a odometer fixed on your car or on your bike. Odometer means by which you can able to measure the speed. And you see, as you are changing the accelerator, the speedometer, that means the odometer, is changing the speed. But along with the concept of average speed, it is not digestible for us, because to find the total speed of the car or the bike, you need to cover a certain distance with a certain interval of time, then you have to find the ratio and then you will get speed. But you see, the odometer changes the speeds very faster. So by which process that odometer finding the speed? Because in odometer you are just getting the certain speed in that certain time, that exact time when you are running your car or bike. So that is the problem, which is not going same with the average speed. And for that reason, we need to learn one more thing, and which is important for us, and which you can say it is little newer for you. That is instantaneous speed. Instantaneous speed. What is it? Now, instantaneous speed, by the name only, we just want to understand, or we just want to find the speed just that very moment you are just want to finding out the speed of that very moment when you just want to finding out. So how you can able to find it? So whenever we have to define instantaneous speed, it is told that it is a ratio of distance with a very short interval of time. Okay, distance with a very short interval of time means the time interval. Okay, whatever we have taken t earlier, the time interval we just want to make it small. Initially assume we are finding the distance covered by a body in 5 seconds. Now I am making the time interval small. So assume I am just want to finding the time interval in 0.1 second. Okay, so it is less than 1, it's very close to 0, and that time how much speed is got by a body, that is known as instantaneous speed. How we can represent it? We can represent it by this way: limit del t tends to 0. What is del t? The del t is known as the time interval. Limit del t tends to 0 delta x by delta t. Delta x is the distance and delta t is the time, where delta t tends to 0. That means delta t is very small. Delta x by delta t. Okay, so as time interval is small, delta x, that should also be very small, and that can be represented by dx by dt. So we can say that v instantaneous, that is equals to dx by dt, and it is known as differentiation of x with respect to time. Differentiation of x with respect to time, and this concept is newer to you. Similarly, whenever we have to find instantaneous velocity, whenever we have to find instantaneous acceleration, every time this differentiation is important for us. So our next target is to learn what is differentiation. I'm telling again that we are not bothering the common things what you have learned in class 9. I've again told the general definitions, differences, along with the graphical representation of motion that you have done in class 9. My suggestion is go through it, and if you are having any doubt, then only I will discuss this thing. Otherwise, we will just start the new thing. So today you just try to learn what is differentiation, and then if you are having any doubt, you ask me, I'll clear it out. What is differentiation? That I will explain. But what is the need to learn of this thing? It is a mathematical, you can say, formulation. But what is the need to learn this thing in physics? I have already told that in physics we just want to learn the laws of nature. So to learn the laws of nature, we need some tools. Just like if you want to learn a new language, you need to learn about the alphabets. So here alphabets are the tools. And here to learn the laws of nature, that means the physics, we need the tools of mathematics. So there is one of the tools, that is differentiation. What is differentiation? Now in differentiation we learn the change of one quantity, that means definitely a physical quantity, with respect to a small change of another quantity. What is it? change of one quantity with respect to the small change of another quantity. Just like if I am talking about a plant, assume when I have done the video, that is 5th June is World Environment Day. So here assume you are planting a tree. Okay. So assume day by day, whenever you have to see the height of the plant, it will increase. That means we can say more time, more height. That means here you see the time and height, there are two quantities. So by the change of time, the height is increased. By the change of time, the height is increased. So by change of one quantity, the another quantity is changed. And in differentiation, we just want to learn the change of one quantity, that is height, with respect to a small change of another quantity, that is time. Means with respect to a small change of time, how much height is increased. That is only differentiation, nothing else. It is not a hard thing. I'm telling it's the easiest one. Okay. Now I'm coming, what is the need of learning differentiation here? In the first part, I have already told that our target is to learn mechanics. That means the motion or rest of a body. So whenever we have studied about motion, one term has come, that is instantaneous speed. We have learned about speed, velocity. So whether it is instantaneous speed or instantaneous velocity, what it tells? It tells instantaneous speed or instantaneous velocity is basically the ratio of displacement or distance with time in a very short interval. Okay. That means in a very short interval of time, how much distance you have covered. Okay, that is instantaneous speed or velocity. I think this one, it is explained very well in the previous part. So here I don't want to express it properly. But what is differentiation? What we want to learn from differentiation? Let's see. I think in class 9 only, you have already learned the graphical representation of motion. Okay, so with respect to time, how the distance, speed, velocity is changed, that part you have already done. Here also, we want to do such type of thing. Assume, I just want to show you a graph. Assume it is y, it is x. Okay, so one quantity I have taken along y. I am not fixing any quantity. Assume there is one quantity along y and there is one quantity along x. And we know that that type of quantity we have taken along x axis, which is independent variable, and depending on it we have taken y. Okay, so we can write that y is equals to function of x. What does it mean? It means that depending on the x, the value of y is changed. Okay, it's a very common thing you have learned earlier in class 9, 10. Okay, now assume this y versus x graph varies like this way. Okay, it's arbitrary. I have taken that y versus x graph is varies like this way. And in this graph, I have taken 2 points. This is point number 1, which is taken as A, and this is point number 2, which is taken as B. If anyone asks you that what is the position of A, so what we have to do? Now we have to draw a perpendicular here along x-axis. Assume this distance, it is small x, and if I have drawn a perpendicular on y-axis, this distance, it is small y. So the position of A, we can represent it is x comma y. It's a very common thing. Okay, now talking about B, what is the position of B? Now you see, it is more than x, right? The position of B along x-axis, it is more than x. So assume this is x plus delta x. So it is clear that this zone, it is delta x, which is more than x. Okay, and if I have drawn a perpendicular here, okay, it is more than y. So we have to take it is y plus delta y, and this one, it is delta y. So what basically we just want to do, we want to find the position. The position of B is y plus, x plus delta x, comma y plus delta y. Okay, so these are the positions of A and B. Okay, now whenever we have to draw a graph, we just want to find the slope of it. We just want to see that with the change of x, how much y is changed. That is our target. With the change of x, with change of x, how much y is changed. So here you see, with the change of this small length del x is what? That is change in x. How much y is changed? Now from y, it is changed to y plus delta y. So we can write by changing delta x, y is changed by delta y. Means delta x is changed, so here y is changed by delta y. So how much y is changed with respect to delta x? So we can say the change should be delta y by delta x. By the change of delta x, the y is changed by delta y. Okay, and now you see, when we are talking about delta x by delta y, if I have drawn a perpendicular here and if I connect A and B, so if this point is C, so you see triangle ABC is a right angle triangle. Right? And here we have seen one angle here. What is it? Assume it is theta. So we can write that tan theta is equals to perpendicular by base, that is BC, by AC. What is the length of BC? The length of BC is delta y. So put the value here, delta y. What is the length of AC? Delta x. Delta x. So whenever we have find with the change of x, how much y is changed, that is basically your slope, because we know slope theta, we can calculate it by tan theta, because as theta is small, tan theta nearly equals to theta. So we can mention that slope is equals to delta y by delta x. That means whenever we have to make a differentiation, basically in graphical method, we just want to find the slope. In differentiation, what we want to do, that we want to find the slope, right? I think it is clear, because I think whenever we have just learned that graphical representation, there we have learned that slope calculation for a graph, it is how much important. And what is slope? Slope is angle made by a line with x-axis, that is this angle. Okay, now you see here A to B, that is change is shown. The A to B, it is changed. The black line I have shown in this way. But whenever I just want to find the slope, we have to take a straight line, that is the dotted line in blue color I have drawn. So A to B, the change is not linear. That is a problem. We can mention that from A to B, change is not linear. Why? Because you see, the change is occurred by this path, this carved path we have seen. And whenever we have to find the slope, we have to take a straight line, that is a linear. So here, whenever we have to find slope, there must be some problem, because you see, the slope, whenever the theta I have drawn, that exact angle will be with this, with the black line, but I have drawn with the dotted line. There is a problem. How we can able to sort out the problem? Okay, let's see. Now in our next target, what we have done, that if B point is approaching towards A, if B point is approaching towards A, means initially we have taken B is here. If I am taking B is here, now we have taken B is here. Okay, B is approaching towards A, then we can say, then delta X will be decreased. Okay, and along with it, delta Y is also decreased. Simple thing. Okay, don't take it very complex way. As B is approaching towards A, so definitely now the size of the delta X will be this. If it comes more closer, then the size of the delta X is this. So delta X is continuously decreased. As the delta X is decreased, you see the height, that is the delta Y, that is also decreased. Assume by approaching closer, if B is coming very nearer to A. If B is very close to A, but don't assume that B is just overlapped with A. Okay, so we are mentioning what thing? It might be little bit of difficult for you that to think about it, but just try to understand that if B has come very close to A, in this case, delta X will be very small. Okay, in this case delta X will be very small. So delta Y will also be very small. So it's a story. Okay, I am writing all the things here to make you understand properly. We are assuming the B is approaching towards A, so the delta X will be very small, as well as the delta Y will also be very small. And then what we have to assume, I am just erasing this portion because it is not needed now. I just want to show you one more diagram. What is it? The same diagram. Along it is X, it is Y. The graph seems to be like this. Okay, so here this point is A, and assume the B point is almost very close to A, very close, almost nearer to A. So here, if I just want to find the slope, then that will be tangent of A, because if B is very closer to it, A and B is very much closer to it. So if I want to draw a straight line from A to B, see, A to B we have drawn a dotted line now. So in this case, A to B line will be the tangent through A, because the line is so, the point, 2 points A and B is so closer, then we can mention that the slope of A and B will be the tangent on A. Okay, it's very easy. As B is coming closer together, then if I draw a straight line between them, it is almost just like a tangent. Okay, and here delta y and delta x is very small. So how we have to represent it, this delta y and delta x? So we have to represent it like this way, that limit delta x, what we have taken, is tends to 0. Tends to 0 means A and B is very close. So to show it very closer, we are taking that delta x is tends to 0. So if delta x is tends to 0, then delta y by delta x, that can be represented by dy by dx. Okay, what is it? What does it mean by the word limit? Limit means we are assuming that how much the ending value, the minimum value it can be. So it can be goes tends to 0. Tends to 0 means it is a complex thing, you have to understand. Tends to 0 means it is not exactly 0 but very close to 0. Assume if A and B is so close together that their distance between 0.002 centimeter, so we can say that this length is almost 0, and that's why if delta x is tends to 0, then delta y by delta x, that is denoted by dy by dx, and it is known as differentiation of y with respect to x. What is the meaning of it? The meaning is by changing the small value of dx, how much y is changed, its ratio is known as its differentiation. By changing very small value along x, that is dx, how much y is changed, its ratio is known as differentiation. Okay, so differentiation of y with respect to x. Why I am starting it with instantaneous speed? So in instantaneous speed, you might remember we have write that limit along x-axis in the case of instantaneous speed. So along x-axis we have taken time, and along y-axis we have taken distance. In a distance time graph, instantaneous speed, you see, when del t, that means change of time, tends to 0, that means the time interval is very short, then delta y by delta t is equals to dy by dt. We already know that the slope of distance time graph, that will give us the velocity, or I'm sorry, the speed. And if I'm talking about motion in one dimension, the speed and velocity is same. So dy by dt, that is the slope of distance time graph. And we all know that the slope of distance time graph we can get, that is the speed. So if distance is given to you, if you differentiate it with respect to time, then you will get the speed. That will come to discuss little later. But my target is to make you understand what is differentiation basically? So differentiation is nothing but the ratio of two quantities where one quantity is changed and with respect to it some another quantity is changed, and its ratio is known as differentiation. Okay, and sometimes it is known as derivative also. Okay, same thing. Clear? Now with the help of differentiation, what the things we can able to find out? We all know that number one, the slope of distance time graph is equal to speed of body. So if I got a distance of a body, it is given to us. If I find the differentiation of it, I can able to find the speed of the body. How we can able to differentiate that? I am coming little later. So we can say the differentiation of distance with respect to speed, with respect to time, I'm sorry, with respect to time gives us speed. Okay, because we have already seen that differentiation is nothing but slope of the graph. Differentiation is nothing but slope of the graph. Similarly, we know that slope of velocity time graph, that is equals to what? Acceleration of body. We have already done it earlier, na? We have already done it whenever we have read the graphical representation of motion, and from here we can mention that differentiation of velocity gives us velocity with respect to time gives us acceleration. You have to remember this thing, that differentiation means slope calculation. Differentiation means slope calculation. Now there are some rules in differentiation, okay, and that rules you have to remember. Okay, so we cannot able to how it has come. So 2 or 3 I will show you that how we can able to find it, but mostly you have to write the laws, the rules, so that you can able to do it. Okay, okay, so here I have shown you some differentiation of some common functions along with some rules of differentiation. So by seeing it, don't think that you have to remember all the thing. Definitely you have to remember, but it is not seems to be very hard. By seeing it, it seems to be very hard, but it is not like that. It should be very easy, and you can do it also very easily. Whenever we have done some numericals over it, then I think you can able to understand each of it. So before that, first you see what are the functions are given, right? X to the power n. If y is equals to x to the power n, then dy by dx should be n x to the power n minus 1. Example, if it is told that y equals to x square, okay, so here the value of n is 2, y equals to x square, and in this case dy by dx will be, so here it is n x to the power n minus 1, so 2 will come here, 2 as a form of n, x to the power n minus 1 means 2 minus 1, so it should be 2x. Okay, if it is x cube, assume instead of x square, if y equals to x cube, so here dy by dx, it should be n x to the power n minus 1, so 3x to the power 3 minus 1, so 3x square, just like this way. Okay, now you might be thinking from where the rule has come. So I'm giving you a little glimpse of that rule. So assume if you see y equals to x square. Okay, so you have to find dy by dx. Now to find dy by dx, whatever, just remember what we have done earlier. Okay, so earlier in the graph we have seen that x square is this. Assume that x is changed by x plus del x. So we can write if x is changed by x plus del x, then y equals to y plus del y. We have done it earlier. If x is changed by x plus del x, then y will be y plus dy. So here you see y plus delta y, it should be x plus delta x whole square, because the x is changed into x plus del x whole square. So here x plus del x square means x square plus 2x del x plus del x square. Very simple thing, a plus b whole square. Now you see x square equals to y. Okay, so we can write y plus delta y is equals to y. Instead of x square we can write y plus 2x delta x plus delta x square. Now you see I have already told that the value of delta x, that means the change of x, that should be very small. So the value of delta x, it should be very small. How small? Assume that value of delta x is 0.01. Assume, it's an assumption that value of delta x, it is 0.01. So if I make it square, that is delta x square. So delta x square means 0.01 whole square. Then what will be its value? Its value will be definitely 0.01 into 0.01. So we can write 0.0001. You see the value of delta x and delta x square, as delta x is small, so delta x square is very small. So we can able to neglect this. We can able to neglect this delta x square. So y plus delta y equals to y plus 2x delta x, right? So I am writing little smaller so that it will be just delta y, it will be 2x delta x, right? And here you see delta y by delta x, it will be 2x. Exactly whatever we have seen, that is differentiation of x square, it will be 2x. So that is an example. So by that we can able to find the rule that x to the power n, if y equals to x to the power n, then dy by dx equals to n x to the power n minus 1. Your homework here, I have told it's homework number 1. Just find it if y equals to x cube by this way. Okay, if y equals to x cube, find delta y by delta x. Okay, you just find it by this method. Okay, and then also you will see it will come 3x square. Okay, and that's why the rule has come like this way. So I'm erasing this thing. Now the next function, if y equals to sin x, then dy by dx, it should be cos x. If y equals to cos x, dy by dx will be minus sin x. If y equals to tan x, dy by dx equals to sec square x. If y equals to cot x, dy by dx equals to cosec square x. If y equals to sec x, dy by dx equals to sec x tan x. And if y equals to cosec x, dy by dx equals to minus cosec x cot x. So this portion, this is totally a trigonometric values. So let's see one how it has come, how differentiation of sin x, it will be cos x. Let's see it. Whenever we have to take y equals to sin x, now what we have to do, we have to replace x by delta x. Okay, replace x by x plus delta x. So we can write that y plus delta y equals to sin x plus delta x. It's a very simple thing. Okay, so if x is changed by x plus delta x, then y will be y plus delta y. Now sin a plus b, we know that sin a plus b equals to sin a cos b plus cos a sin b, right? Sin a cos b plus cos a sin b. Okay, that thing is clear for us. Okay, now from here you see y equals to sin x, we have already taken y equals to sin x. So here we want to assume one thing. What it is that? The thing is, if I have to write here, it's a little smaller thing, I have to use another color. If delta x is small, then cos delta x is nearly equals to 1 and sin delta x is nearly equals to delta x. Now you might be asking, sir, from where this thing has come? You will understand later that you have to learn when infinite series, then you have to understand that cos delta x can be represented, or cos x can be represented by 1 plus x cubed by 3 plus x to the power by 4, x to the power 5 by 5, like this way. Okay. Now you have to just remember only one thing, that if delta x is small, then cos delta x is nearly equals to 1 and sin delta x is nearly equals to delta x. Okay, so replace that thing, that is y plus delta y, it is equals to sin x plus cos x delta x, right? Cos x, and instead of sin delta x we can write delta x. Sin x equals to y, so this y will be cancelled out. Delta y, it will be cos x delta x, and delta y by delta x, it will be cos x. Okay, so here the differentiation of y with respect to x, where y equals to sin x, it will be cos x. Okay, similarly you have to do by this way, when y equals to cos x, find delta y by delta x. That is your homework by this method. Okay, and then you will understand that how this rule has come. But if you are not able to understand how this rule has come, then you just able to remember this chart. You have to memorize it, that if it is tan x, then it will be sec square x, if it is cot x, then minus cosec square x. Like this way you have to remember. Okay, now coming the last two, ln x. If y equals to ln x means log x with base e, then dy by dx equals to 1 by x. This one, to learn this also, you have to understand log. I think you have learned log in class 10, but here in class 12 you have to understand, you have to learn about the logarithmic series. Okay, so assume I have given an example that if y equals to ln x, now if x is changed by x plus delta x, then y equals to change by y plus delta y. So ln x plus delta x. Okay, now from here we can write it like this way, right? Ln if I take common x, so x 1 plus delta x by x, we can write it. So we know that ln a into b, if it is a and if it is b, okay, so it can be written as ln x plus ln 1 plus delta x by x. Okay, so here you see y equals to ln x. So delta y is equals to ln 1 plus delta x by x. Okay, ln 1 plus delta x by x. Now you have to learn logarithmic series. What is logarithmic series? In logarithmic series, it is told ln 1 plus x, it is equal to x plus x square by 2 factorial plus x cube by 3 factorial. Like this way it will increase. Okay, so here ln 1 plus x, and here the x should be less than 1. Okay, this is del x by x. So you see one thing here, it can be represented by del x by x. So instead of x we can write del x by x. Okay, next one, del x by x whole square by 2 factorial, then del x by x whole cube by 3 factorial. Now you see, as del x is small, so this all higher power term, it gonna be 0. Simple thing, as del x is smaller, so then del x by x is very small, so its square, that should be very small, so we can neglect this. So we can write delta y is equals to delta x by x, and delta y by delta x is equals to 1 by x. That is the thing it is given. So dy dx of log x, okay, that is ln x, that is 1 by x. Okay, if you just don't want to understand how it has come, first of all you have to learn the logarithmic series. Till now you have not learned, I know that. So then you have to remember this thing. Very simple thing. Same thing for e to the power x also. Exactly same thing. Let's do it. How e to the power x has come. So this derivation is not needed. Definitely it is not needed in physics. Okay, but I have to do it because you have to understand from where the equation has come. Yes, you can able to memorize this chart, but apart from that, you have to understand from where it is come. So if y equals to e to the power x, so y plus delta y, then x should be changed by x plus delta x. So x plus delta x means e to the power x into e to the power delta x. Okay, and here there is a series of e to the power x also. It is called exponential series. What is the series? It is called 1 plus x square by 2 plus x cube by 3, like this way it is increased. Okay, just like same like logarithmic series. So here definitely e to the power x, it should be as it is. E to the power delta x can be written as 1 plus delta x square by 2 plus delta x whole cube by 3, so and so. So definitely delta x is small, so this higher power term, definitely it's gonna be 0. So it can be written as e to the power x into 1 plus delta x. Now you might be asking, sir, why we are not breaking this e to the power x? We are not breaking because here the power of x should be very smaller, then only we can able to use that series. So here delta x is smaller, that's why we have used. So here it is e to the power x plus e to the power x delta x. Y equals to e to the power x, so y cancel out, delta y is equals to e to the power x delta x. and delta y by delta x is equals to e to the power x. Okay. Again, I have told, if you are not understanding that from where this equation has come, then don't be panic, because it is not important for your syllabus. I have just only shown that how this thing is come. For yourself, if you remember this one only and up to this, your work will over for board exam. If you want to attend in joint or neat, then you have to remember this chart, nothing else. Okay, rest of the thing is same. Coming to some rules in differentiation. So these are some common functions where we have to see the differentiation. Now we are talking about some rules. So when we are talking about rules, d dx of cy means c is a constant. So here the differentiation will be c into dy by dx. Just like if assume it is 5y d of if assume it is y equals to 5x. Okay, so it is 5x. Okay. So d dx of 5x. So d dx of 5x means 5 into dx by dx. So it is 5. If it is d dx of 5y, so 5 will come outside, it is dy by dx. Okay, assume if it is d dx of 9 x cube, d dx of 9 x cube. So here 9 is constant, so 9 will come outside. So it is simply d dx of x cube. So which rule we have to follow? We have to follow this rule, n x to the power n minus 1. So 9 will come outside, n x to the power n minus 1. So it is 3x square. So 9 into 3x square. So it is 27x square. Very easy. Okay, 27x square. Okay, so this is the first rule. Now coming to the second rule, that is d dx of u plus v, where u and v both are function of x. That means u and v are not constant. That can be changed with the change of x. Okay, let's see an example. Then it will be very much easier for you. Assume it is told that let y equals to 5 sin x plus 2 cos x. Y equals to 5 sin x plus 2 cos x. You see, y, it is a function of x, where this one and this one separately, these are function of x. So it is u, it is v, right? Whenever you have to differentiate it, dy by dx, then definitely 5 will be constant, then 5 will come outside, d dx of sin x, and plus 2 is constant coming outside, d dx of cos x, right? So 5 d dx of sin x means sin x differentiation, it is cos x. So 5 cos x, and d dx of cos x, it is minus sin x. Okay, so what is told here? If d dx of u plus v, where u and v both are function of x, then it should be du by dx plus dv by dx, just like the rule of multiplication whenever something is there in bracket. Coming to the third rule, that is also very easy. What is the third rule? Third rule is d dx of u into v. Here also u and v are function of x. Then it will be u dv by dx plus v du by dx. Let's see how it is done. Assume y, it is given you e to the power x sin x. If y equals to e to the power x sin x, so you see e to the power x, it is also a function of x. Sin x, it is also another function of x. So e to the power x, we can take it is u, and sin x, it can be v. So when we have to do dy by dx, so you see first which one is constant? U. So what is u? E to the power x. So e to the power x is constant, and then dx of v. So what is v here? It is sin x. Next, v should be constant. That means what is v here? Sin x. Sin x is constant. Dx of u. So dx of u, that is e to the power x. Okay, write it. E to the power x, ddx of sin x means that is differentiation of sin x. Ddx means it is d by dx. Sin x, here the function is sin x, so it will be cos x plus sin x. Ddx of e to the power x, we know that it is e to the power x. Okay, so e to the power x cos x plus e to the power x sin x. That is the differentiation. Okay, so now it seems to be a little bit of difficult for you, but step by step, whenever you have to do it, these things will be very much easier. Okay, coming to the next one, number 4, ddx of u by v. Ddx of u by v, where u and v both are function of x. U and v both are function of x. So let's see it. Okay, one function y equals to, assume it is cos x by x. One function is given to you, that is cos x by x. So here you see cos x, it is also function of x. We are taking it is u, and x, it is v. So it is u by v form. How we have to differentiate it? So differentiation dy by dx, it is very easy. V square, what you have taken v here? X square. Okay, now this v will come at top. So what is v? That is x. Dx of u means du by dx. What is u here? Cos x. That means dx of cos x minus u should be constant. What is u? That is cos x. Cos x and dx of v means dv by dx. So ddx, what is v here? That is x. Okay, now differentiate it. X, ddx of cos x equals to minus sin x, and plus, I'm sorry, it's minus cos x ddx of x. So dx by dx means it is 1. Okay, by x square. So it is minus x sin x minus cos x by x square. That should be the answer. That is d dx of cos x by x. Its formula. Okay, I think it is clear. Now we have to go for the last one, that is dy by dx, that is equals to dy by dz into dz by dx. What is it? Okay, let's do it. Assume one thing is given to you, that y is equals to 5z square. Okay, you have to find out dy by dx. Now it is mentioned that z is function of x. Then how we have to do? Okay, because here no x is given and z is not constant. If it is constant, that is another rule I have told you. If it is constant, we have to mention here 0. That is the rule number 0. That is d dx of any constant, that is c. That should be 0, where c equals to constant. So differentiation of any constant is 0. Why it is 0? I have already told differentiation means we just want to find the change of one quantity with respect to another quantity. But if it is a constant, definitely there will be no change. If you change one quantity, if it is a constant value, it can never be changed. So the change will be 0. That is the differentiation. So dy by dx can be represented by dy by dz into dz by dx. What is the value of z here? And the value of what is the value of y here? That is 5z square. So d into 5z square by dz into dz by dx. Okay, just we have multiplied in ups and downs by dz. If you differentiate it, it's very easy. 5 will come outside, dz square by dz, that is simply x to the power n. So what it is, z square, as you differentiate with respect to z, so this value will be changed by z, so it is 2z, because n z to the power n minus 1, as like nx to the power n minus 1 into dz by dx. So it is 10z into dz by dx. Okay, it seems to be little bit of confusing, but I don't think it seems to be very hard. Okay. So these are the rules of differentiation. So we can able to practice some numerical from this differentiation in the next video. Okay.